All right, let's. Here comes people joining. Hi everyone. Just give me 1 second just to share my screen first. And that'll be it. So small adjustments. I think we are good to go. So hello everyone, and thank you for joining us in this second event on effectiveness and collaboration. This time we'll be focusing on data. So a little context on that. We created those shorter event series, like below 30 minutes, to kind of emphasize on some of the core components of an effective ML platform. And in our opinion, that comes in 4 different sections, right? There's teams, data, performance, and deployment. We already talked about teams, and that was our previous event. Do feel free to check the video recording online. And what we touched on last time was the collaborative aspect and kind of the project space and how that helps collaboration across the teams. And here you see kind of the overlapping of the different teams, engineers, data scientists, ML engineers, and business analysts within that project space. And that allows each teams to kind of first of all, share their assets and so on, but also to collaborate within the same use case. And I think this is important. So we kind of demonstrated how collaboration and team collaboration is overdue. And now we will kind of demonstrate how data sharing and the data aspect of an ML platform are extremely important. And to support me in that argument, I'll be showing you some context. And so one is a reference from Deloitte, and I think it's a rather recent content they've been producing just last year. And so essentially it says that the volume is increasing, and we all know that the number of data points, the number of data sources is increasing, and therefore we should be able to turn that data into AI application to help businesses in the decision-making process. So that's an argument on the volume. One of the aspects of the complexity comes from just the sheer amount of data that we have. The second is the diversity and the variety of sources, and I really like that quote from Matignon, which is that a mean number of data sources per organization is 400. And for some of them, 20% of them, indeed, that's 1,000, over 1,000. And so those are the data sources that power our BI and analytics tool, but that will be the data source that will power your AI too. And so it's important to understand that the complexities of the data that kind of emerge from the analytic worlds are also brought toward the ML worlds downstream. And another aspect, something that we often mention about the models in production or the lack of models in production, one is the team communication, and I've touched on that last time. But another aspect is obviously the accessibility of those data to those teams. And so we essentially want to solve that. But I guess first we have to all talk about the same thing. So what is the data we are talking about? And kind of how does it look like? So in analytics and business, you would have this kind of tabular data, structured data. And I like to call it data for humans because it's readable by me, really. So I will have a customer row, I have a country row, I have spending. Maybe this is in order to predict churn. So we'd have a yearly spending of that customer. But I would need to translate that data for machine learning to be able to be produced. And that will look something like that. So this is featureized data. Those are features. And you will see that instead of actual words like the country name and all, you would have binary options. It's not UK, so it's 0. It's not US, so it's 0. And it's one of the other. And therefore France is 1. and you will have the data featured in such a way. And you will have to keep that data being featured in such a way so for your model and your algorithm to understand it, because they simply do not speak the same language as we do. And that process is essentially feature engineering, and that process you need to bring it along as you create your pipeline. Moving to the pipeline, how does it look like? You will have a raw data that feeds your data source. So that's your data warehouse or database, any kind of model that you have in your organization. And so raw data to data source engineering, so that's the process of creating those features. And from those features, you will create groups of them, and we like to call them feature groups. And I think overall, across all fields now, we pretty much agree on the naming convention for this. But that will be your, let's say, standardized one-to-one ML pipeline, data source to feature groups, and then training data sets. If you go there, training data sets, and you will have serving. And this is essentially like one model, one pipeline. And it creates a certain, I mean, you could do that just right away, maybe in a notebook and maybe already in certain data warehouses, but you are probably removed for a certain amount of complexity if you just keep it at that level. Because let's say you do an online serving, maybe you have some application data that needs to be fed to the serving. So let's imagine, for context, the form submission. I really like this example of insurance, right? Maybe it's a claim, right? And maybe you have a form to submit to claim some insurance money through the website or through the web app, a service, a backend, and so on. And so you would want your model to predict if this is a case of fraudulent claim, perhaps, or something alike. Or maybe it's a scoring system. Maybe somebody wants to apply for an insurance policy and they need to be scored. Anyhow, this is real-time data, and therefore you would want the data to be able to talk back to the training data set and get like the contextual data that serves for the model. The problem is already kind of arising is how do you get the surveying to feature log back to the feature groups? How do you get the information to the training data? And how do you make this whole system communicate together? And that's one side of the challenge that's arising from some of the online aspect, but you also have some other aspects that simply arise by the duplicity of sources. So I have a new source. What do I do? Do I feed it to my same engineering pipeline? Is it a new version? Is it a breaking change? Do I break the previous pipeline, or is it working in parallel, for instance? And let's say that you solve that question by just saying, okay, it's a secondary pipeline. It's a different data source. It does a different thing. It creates a different feature group. Well, excuse me. Perhaps you would want to join those feature groups in order to create complementary, filter and join the features and create the training data set out of the both. And on the, let's say, on the abstract level, that works pretty well because you can see, okay, if I have a third, maybe I do exactly the same. I have the fourth. I have exactly the same, but that is a bit removed from the use case centric approach, right? So let's say that we slap a use case on top of that. Say one of the feature groups is a personal information feature group, and the other one is a historical feature group. So the historical data of a person. And let's say this is for fraud, right? So you would have usually those divisions. So you already kind of create a new complexity, which is, well, who has access to this? And already you can imagine how this kind of spill over to other aspects of the engineering. Who has access to the data source? Who has access to the engineering logic? Who has access to the models, and so on and so forth. And so that's already kind of an aspect of the complexity of the data at this point. And it is kind of only one model, and there's just multiple pipelines to feed that one use case. Now you can imagine that those complexities tag along, and as you scale, they scale with you. We believe we solved this by creating this project-centric approach. And so in our paradigm, data works as feature groups. Feature groups are then feeding feature views, and so you would join multiple feature groups into a feature view, and then you can create your training data set and such. And the feature groups is the essential, let's say, the central aspect of the feature store, and therefore the central aspect of a machine learning project in Hopsworks. And so, what's the anatomy of a feature group in Hopsworks? It has kind of all those elements by default. Each feature group has a version. So let's imagine that you have the same data source. You create you have a new feature, which is a new column, and you would want to create a new feature group out of it. Well, you could create a new feature group, but in practice, if it's the same kind of features, you could version your feature group and just create the version 2, let's say. Data commits, validation rules, like let's say no negative value, or no persons above 200 year old, and so on and so forth. Logs, engineering, schemas, tags. Tags are great for searching across the feature store, right? So let's say that PI data, put a tag, and therefore it's searching across the whole UI. And lineage provenance, so that you can see where it goes and where it's come from. So this is kind of the core element of a feature group in Hopsworks, but kind of there is other abstractions and other complexities that can help an organization cater to any kind of a system they want to put in place. So those are project assets. Feature groups are really the assets of a project, and they are divided in kind of 3 categories. There is the online feature groups, there is the offline feature groups, and there is the external feature groups. And they all have their own application, but essentially, let's imagine that you have Amazon as a data source. You would write a batch through the batch API to an offline feature group to get your historical data. And you could do that multiple times, create multiple feature groups from the same data source, depending maybe on the use of those feature groups, how they've been crafted to cater to specific use case, or maybe just different timeframes, or maybe different location. It's really a project and kind of business-centric approach, because it really depends on how your business wants to solve a specific issue that you will solve through that method. But then, as I said earlier, given that there is so many possible data sources in an organization nowadays, you can actually create multiple feature groups from multiple sources. And in that case, I've put Microsoft Azure here. But you can also have external tables, external feature groups, which are not materialized feature groups. So you do not write the content of your Snowflake feature group, copying into the feature store. You would just have a metadata layer on top, and it's kind of an on-demand approach. And the point of it all is really that you can have all this data logic that allows you to create the feature views, which are the materialized views of the filtered and joined feature groups. And in that case, what I did here is I said that you would join an offline feature group with an external feature group. And you can see how, for example, in an organization that would have a certain amount of features already done, already engineered in Snowflake, and maybe some historical data that is somewhere else in S3, and they would want to join that to start to do some model training without creating complex pipeline. This is essentially where the feature server comes to play. It also comes to play when you start to have a more complex use case. In this case, real-time events. Let's imagine that you have a fraud detection or an anomaly detection system, and you would want something to triggers within a second when somebody does a transaction, either online or with the card and all. Well, you would want a system that has the ability to both kind of get that performance requirement, but also that can communicate with some offline storage in order to get the historical data that I mentioned earlier. And this is where the online API comes from. So if I have more data, what does it mean in this paradigm? Well, kind of the feature groups, the training data, the feature views, the model registries, and so on, they are projects, and they are development projects. If you want them to be development projects, it's up to the user to define what are those projects for. But let's say you have a source, and I want to create multiple feature groups. That's fairly possible. You can have multiple source creating multiple feature groups, or like the same source creating multiple feature groups. That's really depending on the organization logic. So in that sense, you can also just create more projects. So I might have a project that has only offline data and a project that can only have online features. It's not a necessity. You could have online and offline features in the same project. It's really up to the logic, and you would kind of share some assets across the organization to define your business logic. And if you go further down, you could have like multiple sources depending on the use case. And if you look back at that personal information use case I mentioned earlier in the very first frame, let's kind of put it here. And imagine that you would have those personal information and say, all right, but I don't want the rest of my organization to have access to the same kind of assets, right? Because this is personal information, maybe only a portion of my team can. Well, then you just don't share those assets with the rest of the team, and you divide your pipeline and you're depending on your business logic. And this is where your data can come from multiple sources, from different methods, online, offline, or external, and also depending on the logic of the data that you want to apply. And so ultimately, you can use those projects to create those more established frame of work, like the continuous integration and continuous development, but applying that to machine learning, because you would have development projects like sandbox projects up to as many as you want, really. You would have a staging project, so moving to pre-production, and you would have the actual models in production. And this would help you speed up the thing that matters, at least in our opinion, the most, which is to put the use case in production, to put models in production. So you would spend less time. You would spend less time crafting features because you wouldn't be able to reuse them. You would spend less time on architectural and kind of engineering aspects because they would be embedded, and you would have more time into improving the models and putting them in production. I think it's a common trope that something like 6 months to a year for a model in production is the time, kind of the scale of the time. We've seen this happen within a month's time with the proper infrastructure behind. So this is also kind of the promise of a centralized ML platform. So it all comes to be an open platform, and that all comes to the APIs and connectors that we provide. So in our case, Pandas, Spark, Flink, Spark Streaming, but also the storage connectors, and the more the better. Here you will see that I didn't put Google, but that's not a work in progress. That's almost that if not the next release, the one after next. So that's coming extremely soon. But that also allows you to remove yourself from one single ecosystem and maybe some vendor locking logic there, and kind of work around the organization and any data sources that that might just fit. So in our paradigm, we are kind of project centric. So that will be what I mentioned earlier. You have feature groups, feature views, and so on. But you can go one level higher, and each of those projects have their own UI, they have their own API, their own engineering logic, and that allows you for certain amount of governance. And all of that comes with another extra layer, like an onion, with the connectors that I just mentioned. And really, like what we come to is essentially looping back to this CI/CD logic, whereas you will have a project dedicated to a certain use case with its own data assets dedicated, depending on each team members that have to work on those specific assets or not, but also in creating non-breaking changes if so required, and not breaking production if you already have things in production. So this is centralized information, centralized data, centralized feature stores. Like, yeah, that's about it for this short one. I'll be taking a few questions. I've seen one at least, so let me just go there. Okay, one. And I've been told to name the people, otherwise it looks impersonal. Alexei, if I have my features done in Snowflake, why do I even need a feature store, feature groups, and so on? Yeah, I mean, objectively, if it's just to create one model, maybe you don't. But at the moment you want to scale, actually at the moment you're in an enterprise and you have an enterprise requirement for your machine learning, perhaps you do need a feature store, and that comes from the metadata layer. So the tags, the lineage, the statistics that you might have from the features, and also the kind of complementarity with other data sources that you may not have from Snowflake, right? I think there might be a more precise answer somewhere, and I will data where here goes. I go there often. Here goes. So we have this great article about feature store versus data warehouses. There is some of the aspects that really are similar in the sense that it stores data, but then there is the online offline aspect, which means that, for example, in the case of a feature store, you would have an online storage and an offline storage, and they might have like different performance requirement and so on. Yeah, so I invite you to read this article. I'm sure you'll find much more satisfying answers over there. Carlos S. What is the limit? Okay, how many features per feature group? How many feature groups per project? How many projects? Well, I do not know about the projects and I do not know about the feature groups, given that I don't think we've reached that case, right? So I don't think we ever had anybody coming to us say, "Oh, I need more feature groups." I think it's quite rare. So I wouldn't know exactly. I suppose there might be some pure technical limits, but then you would overcome them by just creating a new project with new feature stores. I don't think there is a limit to projects that will be just purely technical. There is a limit though of features per feature groups. That's something around a few hundreds. I think it's 500, and that would depend on the data type as well. So maybe a certain data type might be more heavy, I guess, and that will reduce the number of features that you can do. Again, those are not really limitation in such that you can always create more feature groups, or maybe you wouldn't have those limitations in feature views, but joining feature groups. So those are really, I don't know if it makes much sense to talk about limitation in that case. But if it is a specific use case, I'd be happy to give you a proper answer or get you somebody who can get you a better answer. Okay, Vadims. This is how this is how to write into the feature store. How do I get the data out? So this would be on the storage connector aspect, and that would be perhaps the same way. You would use the same connectors that you write your offline feature groups with to create your training data sets. So you can write to S3, Google Cloud, Azure, Data Lake Storage, ADLS, and you would use the same connectors. Okay, there is one about governance compliance. What about governance compliance and access? Asks Jana. I mean, it looks like maybe you asked this question a bit earlier, so I think I've touched on it on the project here. So it's really a matter of organizational logic that, well, like what I said about the personal information, right? So if you have a team that is dedicated to a specific kind of data, you would give them access to it, and maybe the other teams would not have a read access at all. So you have project owners, and you would have read write kind of abilities across projects. You can have access to all the projects as a data owner. You can have access to only one project. It's up to the organizational logic. So you create your own data mesh kind of logic. You can create your own projects logic. You can create your own organizational logic with Hopsworks. And I think that by definition also implies that, well, first of all, it is compliant, at least in terms of GDPR. Because if you don't want to store anything, it's really just up to you. But if you want to anonymize anything, that's just an engineering principle. So you can go up the upstream in the data warehouse and say, okay, and anonymize every data that gets into the feature store. And then, as I said, once it's featureized, it's anonymized as well. So you wouldn't get any user data at that point. But again, this is more of an organizational logic, so it's really up to the organization to define those upstream and you know, at the beginning. And we are also here to help on that compliance and governance aspect. And I think I'm pretty much on time. And so this is a short talk, really. We try to keep it under 30 minutes and just get into one aspect. So I've spoken earlier that we had the team one. I do invite you to look into the recording. The recording for this one might be available tomorrow, I think, once we process it. And we will also have a few other events. So we will have an event on performance coming in coming months. I think that will be on throughput, latency, and scalability, perhaps more engineering-driven talk, and probably a speaker. But yeah, so simply, if you want to follow up on that, you can just follow us on LinkedIn, kind of like, and you can also just go on Hopsworks.ai and instead of contacts, events, and you will have the list of events that is programmed. In the meantime, I wish you all a nice evening or morning or else, depending on where you are. And I hope to see you soon. Thank you.